The second law of thermodynamics is a fundamental principle in physics. It tells us about the flow of energy in the universe. In simple terms, it states that heat, or thermal energy, naturally moves from hotter objects to colder objects. Imagine a hot cup of coffee left on a table. The heat from the coffee will always flow outward into the cooler air, not the other way around. This principle also applies to other forms of energy. Think about a ball rolling down a hill. The ball naturally moves from a state of higher potential energy at the top to a state of lower potential energy at the bottom. It won't spontaneously roll uphill again without some external force acting on it. The second law tells us that energy transformations are never perfectly efficient. Whenever energy changes forms, some of it is always lost as unusable heat energy. This is why, for example, your car engine gets hot when it runs. The second law of thermodynamics has profound implications for both living organisms and machines. In living systems, energy constantly flows from areas of higher concentration to areas of lower concentration. We see this in the process of cellular respiration. Cells break down glucose, releasing stored energy to power the body's functions. This process isn't perfectly efficient, and some energy is lost as heat. Machines, too, are subject to the second law. Consider a car engine. It converts chemical energy stored in fuel into mechanical energy to move the car. However, a significant portion of the energy is lost as heat due to friction and other inefficiencies. This is why car engines require cooling systems to dissipate excess heat. The second law highlights a fundamental limitation. We can never achieve 100% efficiency in energy conversion. There will always be some energy loss, primarily as heat dissipating into the environment. Closely related to the second law is the concept of entropy. Entropy is a measure of disorder or randomness within a system. The more entropy a system has, the more disordered it is. The second law states that the total entropy of a closed system always increases over time. Think about a messy room. It's much more likely for a tidy room to become messy over time than for a messy room to spontaneously become tidy. This is because there are many more possible disordered arrangements than ordered ones. In the universe, entropy is always increasing. Stars burn out, objects cool down, and systems tend toward a state of greater disorder. This doesn't mean that order can't exist locally. Living organisms are highly ordered systems, but they maintain this order by constantly taking in energy and releasing heat, thereby increasing the entropy of their surroundings. The second law of thermodynamics is a cornerstone of our understanding of the universe. It helps explain why time flows in one direction, why energy transformations are never perfectly efficient, and why the universe is constantly moving toward a state of greater disorder. Understanding the second law has practical implications. It guides engineers in designing more efficient engines, power plants, and other technologies. It also helps us appreciate the delicate balance of energy flow in living systems. The second law of thermodynamics is a fundamental principle governing the flow of energy and the concept of order in the universe. It's a key to understanding the world around us, from the smallest cells to the largest stars.